everyone. I realize it's February and everyone is so busy, but I'm glad to see a few people here. And I'm glad and passionate about the topic today and the presenter. Unfortunately, Dr. Mackenzie had a teaching commitment and he had to be there today. However, I'm pleased that we could still go ahead with the event. And Mackenzie Lockridge, who has a lot of experience working and teaching at all different levels, elementary, secondary, university level, and has an interest in the design of effective multiple choice questions. And if you know Dr. Mackenzie, that's his area, one of his areas of interest as well. How do you construct effective multiple choice questions? Considering the context in which he works and considering the context in which Mackenzie works, they do design a lot of multiple choice questions, so how can we make them as effective as possible? And that will be the session today. The book is How Humans Learn. It is an interesting book, especially if you get excited about scientific theories on how humans learn. It talks about situated cognition. It talks about emotions and Gardner's intelligence. I think you'll find it useful and interesting. So that's the book, and if you've never been here before, although I think I see familiar faces, then you know there'll be a draw at the end. With that said, Mackenzie, I'm very excited that you're here, and I'll leave it all to you.
Thank you. So thank you again for having me, and I'm hoping to make this somewhat interactive for you. No, there's no coffee yet, so I have to keep you awake somehow. It's coming yet. So today we are talking about problem-solving strategies in multiple-choice questions, specifically in anatomy. How many of you have used or written multiple-choice questions yourself? Good. And what's your experience with them? Do you like them? Do you not like them?
They're hard to write.
They're hard to write. Anything else?
I think it's part of the value in them is how they're developed, and if you can link them to a case or something. I mean, it's a little bit different maybe with anatomy, but if we can link them to something like a real situation, and then there's some problem solving within the question.
Definitely.
Then it makes it a little bit more applied than just like straight up knowledge.
Great. So that leads me into the next question, actually, and that is, what is your basis for multiple choice questions? Are they mostly for kind of understanding facts, or are they more about application of knowledge? Most times, are you focusing on pure fact-based questions, or are you extending it, usually?
I would say extending.
Extending. Okay. Anyone else?
Probably a mix. I think it depends, right? I mean, what you're looking to assess, what the objective is you're looking to assess. It's nice to have, and you have to have the extensions, but sometimes you're just wanting to know, do they recognize this fact?
Yeah, so it's sometimes a mix of kind of from one extreme to the next, or in depth. So today our agenda, we're going to go through the purpose of our research. We're then going to go through the methods that we tested the research, through the results, and then in the end with some conclusions and questions if you have any. Your learning objectives, so hopefully by the end of this, you can tell us or be able to distinguish between question types that target various levels of cognitive function using the ICE model. To be able to define domain-specific and domain-general strategies that students use, to analyze which strategies students are using for each question type, so along with the different cognitive functions, what strategies are using for each. And lastly, to be able to identify teaching methods that can narrow the gap between novice and expert thinking. So starting with the purpose for our research. The first thing is that assessment is such an important part to student learning. And often it's forgotten that students, when they're learning, they need to know and understand why they're being assessed and how they're being assessed. So it's not just looking at the learning, but also aligning our teaching with the assessment that we give. I'm not sure how many of us here are in anatomy specifically, or in biology. But in anatomy, it's almost, or significantly used, multiple choice questions as an area of assessment. And there tends to be an association between multiple choice exam format with memorization, especially for anatomy. So students tend to associate multiple choice questions with that basic retrieval of memorized facts. Right now, there is kind of a lack of research that evaluates how students actually perceive and what strategies they use to actually go through these multiple choice questions. What's neat about this research is that it's actually transferable to other disciplines other than anatomy. So although this research kind of focuses on anatomy, you'll see in the end that the strategies that we find that students are using, it can be transferable to math, to history, to really any discipline. Moving on to our methods. So that was our purpose of our research. And getting into the methods, how we tested this, we chose 6 multiple choice questions, and we based them off of the ICE framework. How many of you are familiar with the ICE framework? Amazing. So I'm going to go through it a little bit, just so we have some clarifications. The whole ICE model is kind of a framework for learning. And the way it does is it kind of targets various levels of that cognitive functioning. The 3 kind of frames of learning are ideas, connections, and extensions. It's really important to note that with this ICE model, it's not always a linear. It's not always you have to go ideas, connections, and then extensions. Sometimes you might be in an extension level question, and you might use, or students might use, ideas or connections to solve that extensions. So starting with the idea level of framework, these are kind of discrete pieces of information. So these kind of informations a student could look up through their notes or through a textbook. So they're specific basic facts, skills, or steps that they've memorized. In math, it might be just remembering a simple equation and just having to have the numbers plugged in. So just kind of be mindful of what might this look like in your field of study, because it does differ between, but the most important thing to take away here with ideas is it's that kind of memorization of discrete pieces of information that a student could look up in their notes or in a textbook. Moving on to connections, getting a little bit more in depth. These are the relationships that students can form between those discrete ideas. So it's not just remembering anymore, it's forming those connections with either past knowledge, so prior knowledge, or it could be within the curriculum. This could mean that in one class, they're connecting it to something they learned 3 classes ago. It could even mean that they're making connections between the cross-curricular, so across the disciplines. Again, I ask you to think about what this would look like in your field of study. So we've had our ideas, a little bit more in depth with connections. This is more than just that memorization part. Lastly, we have our extensions. And this is kind of when students have that aha moment. It's basing it outside of what they've learned in class, applying it to new situations or novel situations that they haven't come in contact with before. And it's at this point where students actually understand their implications of their learning. Why is it important outside of the classroom? When you get to this level of extensions, I did say that a student might be using ideas or connections in order to solve these extensions. However, this is showing that kind of deeper set of learning. So again, I ask you, what might this look like in your field of study? So I have two of the questions that we chose for displaying our ICE model that we gave to the students. And I challenge you to figure out, is this an idea level, connection level, or extension? So just take a second to read through it, and then let me know what your ideas are. It's not me, is it?
Just ask them to be.
So what do we think? Is this ideas, connections, or extensions? Ideas, right? It's that discrete piece of information that they just have to memorize from either their notes or looking back at a textbook, easily can be picked right from their memory. And then this one, a little bit longer. Give you a second to read through it. Everyone had a chance to read through it? And what do we think? Ideas, connections, or extensions?
Connections.
Connections? Anyone else have the same opinion, a different opinion? Connections? We actually label this under extensions because of the fact that this is a new situation. So they might have not been taught about kyphosis before, but they have to apply their knowledge and extend it from there. So it's a new situation that they're building upon. But you do see that little bit of connections within it, right? Connecting the shape of the thoracic cavity to what is happening with the curvature of the spine. So back to our methods, we kind of went through the ICE model and that we developed those 6 questions. After those were developed, we selected a group of second-year undergraduate anatomy students. And from there, 82 were administered a written think-aloud, and 11 of them were administered an oral think-aloud. So because this is a really big, important part of our research, this method that we use, the think-alouds, I'm going to go through a little bit of that. So the whole focus for a think-aloud is to go beyond what they answered. So not just looking at did they get it right or wrong, but actually look at how they went through it and the processes they used and the reasoning they used behind it. We administered 2 different types, a written think-aloud, and this was based off a questionnaire that they got. They were given one of the, either an I, C, or E question, and then they were given a questionnaire that had different strategies that they could say that they used or not. In the oral think aloud, this one was a bit more intensive. It was a one-on-one interview. And in this interview, students were verbally discussing their reasoning behind and as they solved it. So just to kind of help them figure out how think-alouds work, because most of them have not done it before, we asked them to describe what they would do when they got home and they had to put away the milk that they had bought. So some students, if they have never done it before, they might just say, oh, put it in the fridge. But what we're really looking to have them do is walk us through every step. Not just the final product, but how they got there, what they did. Might be including, I walk through, I open the door, I take the milk out of the bag. So it's more than just kind of going through their reasoning, but really in depth. The benefits to these think-alouds is really, really great. So with these, we could actually obtain that rich, deep reasoning process that they are doing. So it's more than just having them say, oh, I did that, or I did this. We're going behind that and actually seeing what strategies they used. It's one thing for them to label it themselves. It's another thing for us to actually have that descriptive data that explains what they did. This allowed us to uncover certain patterns that we'd seen in the data and behind their reasoning process. We would have loved to have all of those 82 also do oral think-alouds, but some of the drawbacks to it are that it's very resource intensive. They range from about 40 to 60 minutes each interview, so there's a time. There's also, you have to have someone transcribing what they're saying, so that's also resource intensive, and have someone go through all of that data and pick out all the strategies. Also, the modeling and practice part is quite difficult to kind of achieve. So you have to really take time to practice think-alouds before you get in the habit of actually saying everything that you're thinking. It's a lot harder than you think to actually explain thoroughly what you're thinking and all of your strategies that you're using behind it. So sometimes a drawback to the think-aloud is that if students are not, if they haven't used it before, they might not actually be showing us explicitly all of the strategies that they're using. They might forget to say it out loud, and even though they are doing it in their mind. So after we had all the data, we collected it, and we used qualitative content analysis to identify certain operators that we've seen as strategies that students used. That brings us to our results. So of the strategies found, we found a total of 16. 11 of them we had already seen before in previous literature, but then there was the extra 5 that were new. Strategies categorized by domain general or domain specific. So of those 16 strategies, those could be divided into 2 separate domains, either domain general or domain specific. Much like the name infers, domain general means that it could be applied through any domain. So remember when I was talking about how this study is transferable? When we look at these strategies, we can see that domain general strategies, you don't have to have specific knowledge in that domain. These are things like adding information, so students reading through a question and adding in information that they remember. Checking, so looking through the options and kind of checking that is right because of this, or that is wrong because of this. Recognizing, so if they've seen it before in class or if they think they might have heard it before. Correcting, that is when they've read through, they've made a decision, and then they say, wait, my thinking is wrong, I need to correct that. Predicting, before they even get to the choices, they're predicting what the answer is going to be. Picking out keywords, that could be keywords within the question, like the question words, or keywords as in things that they're looking for in the question. Delaying, so going through the options, stopping, going back. Comparing language of options, so looking at how the different options differ in their language, if they're similar, if they're different. Reading the question aloud. Asking questions, so they might read through it and ask a question about what they need to find out or what they should know. And lastly, determining the question type. So that might be they determined that the question is just a pure memorization of a basic fact that they need to recall, or if it's more of an application question. So those are our domain general strategies, the 11 that we found, also correlated to the other literature that we've seen. So this is all about across domains, not specifically anatomy. In anatomy, we found that domain-specific strategies, this means they need to have that knowledge of anatomy behind them. And these are the strategies that they use. The first one is visualizing. And this isn't really too much of a surprise for those of you that know anatomy, because anatomy is very based on where structures are located in the body, the relationships between each other. Even in textbooks in anatomy, you see lots of pictures in many methods of teaching anatomy. You have that visualizing factor. They're showing relationships and the locations of structures. You also have recalling. So this is specifically recalling something that they should know from the course or the subject. Mnemonics. This is either rhymes, phrases that they've learned, or even kind of letters. There was one used in the study where they had the word, this is a chalkboard, right? Dark and light to represent sacromeres, the A band being in the dark region, the I band being in the light region. So that's an example of a mnemonic that some students used when going through. Imitating. So in anatomy, it's important, and you'll often see if you're watching an anatomy exam, lots of students imitating movements. So they might be flexing their arm if they're thinking about a muscle, or moving their leg, maybe rotating it. So actually using their body to demonstrate an action. And lastly, personal connection. So this is when students connect the question to something that's happened either in their life or in class. So having that kind of connection to help them figure out what the question is asking. So we found that domain-specific strategies increased as we went from ideas to connections to extensions. So as we went further in depth, we've seen more the need for those specific domain strategies. The highest used strategies that we've seen were visualizing and recalling. You often would see these as well together. This is an example of one student who said, first I tried to remember what kyphosis was, and then what maybe the function implies or implications. I was trying to picture from my notes what this looks like. So you see there, first I tried to remember, that's your recalling, and then trying to picture from my notes what it looks like, visualizing. They're trying to picture from their notes a diagram that they might have seen to help them answer the question. Recalling led to the correct answer usually, so greater than 70% of the time, in all levels. Personal connection allowed students to achieve success in all ICE levels for the oral think-alouds, and in the I and E levels for the written think-alouds. This is an example of the personal connection that they used, one of them used. Also, at the beginning of the question, I thought about when I played sports to compare stable flex position to unstable extended. So they're thinking back to their personal connection of them playing sports and relating it back to that anatomy to help them answer the question. We did notice that in the personal connection, although for oral think-alouds, it helped them answer it correctly in all three levels. In the written think-alouds, and specifically the connections level, it was an 81% of the time it resulted in an incorrect score. We also noticed that when students started to get to those deeper understanding questions, C and E, they seemed to use more metacognitive strategies, like so many of them, and it actually led them to have incorrect answers. So it didn't actually help them get the right answer, even though they were using multiple strategies, which we found kind of surprising. Students, so apart from getting the answers right or wrong, we also found a few implications, such as students still having a negative attitude towards multiple choice questions, as well as students still making the assumptions about multiple choice questions. So they already have this idea in their head that it's maybe trying to trick them, or they're really hard all the time. They already have those assumptions in their head. I'm going to show you 2 examples of that. So the first one, and I remember my friends saying they were confused about this because the answer was too obvious. So that might be something that affects it. And I was kind of a little sketched out because I was like, it can't be that easy. So then I was a little scared about it, but I just left it alone and came back. It's like there's no other way I could answer this, so then I put down the answer for that. So we see here that assumption that they're trusting their friends' opinions. Well, my friend said this, so must be right. We also see that they start to second guess themselves because multiple choice, they have to be hard. They can't be easy. This can't be right. And it even makes them kind of scared and second guess themselves, so they leave it and then they have to come back. This one's a little bit longer, but I would have to try to choose a reasonable answer. Like if I were looking at this and I didn't know the answer, I would have to eliminate 1.5 and 3.5, and then I would be left with 2 and 2.5, because usually the answers that are given, there is always going to be 2 extremes, and I always eliminate those if I'm not sure. And then I leave 2 middle values, and I kind of just make a good guess for that. That's how I usually do it if I do not know. Like one time I took a multiple choice course, not course, but a little class or whatever, and they said, like most of the time profs will put really stupid extremes, and it won't be that, and then they'll put the most middle values, and it's usually the middle value. So this was a little bit long to read, but what we're trying to get through this, from this, is that profs, they put in there a reasonable answer. They always put in 2 extremes, and the answer has to be between those 2 extremes. They even trust that all multiple choice courses, they must be right. So we're seeing those misconceptions and assumptions from students. So from those results, we came up with a few conclusions. I'm going to start with the importance to education as a whole, and then we're going to focus a little bit more on instructional strategies. So from this, usually as educators and faculty, we are the ones that think about the multiple choice questions, and we want to think about why we're using them. But little research has been done on students and how they actually perceive them. So this study was really nice because we evaluated those opinions and student perceptions. So now we have ideas about the strategies that are actually being used. It really highlights the importance of making learning visible to our students. So no longer should we just assume that students are using the strategies that we might think that they're doing. We need to be more effective in showing what strategies students should be using. It's also important because we need to, as faculty and educators, debunk those myths about multiple choice questions. Explicitly telling them that we're not here to trick you, even though they may think that. And lastly, it's important to all education disciplines because it's transferable. We've seen that these domain general strategies are used, and the making learning visible needs to happen through all disciplines, not just in anatomy. So when we say making learning visible, what does that mean? Well, many of the mental steps that experts or educators take are not always explicitly shown to students. So they're not translating very well to them. So how can we help that? So we need to actually explicitly show or model our reasoning process. So instead of just kind of going through a question, you are verbally saying what your reasoning is behind it, how you perceive it, what connections you're making. This is going to help students recognize how the experts actually manipulate that problem and generate a solution. One thing to be careful of is when you're making those mental processes visible, you're not showing connections that they can memorize. Because then it turns into that kind of ideas where they're just remembering from memory, looking at those connections. So you want to show them the strategies to get there, what you're doing to get there, not necessarily showing them something that they can copy down in their notes and just memorize for an exam. Yes.
So, do we really need to change the students, or do we need to change the profs? Because, you know, the students, you presented all these things that students do. I can tell you we've all done those, right? I mean, we were all students at some point in time, and I'm a physician. One of the things I have to do to keep my license is a self-assessment program, and it's like 300 multiple choice questions a year. And, you know, half the time I argue and say, who wrote this question? They're fools. You know, because it's badly written, the question answers are wrong, and, you know, but I use all of those strategies too. Sometimes, you know, I can answer questions that I have no real clue what the answer is. And in the one you had presented, I would have picked two of these as well, even if I had no clue, I would have picked two of these, because that just means the prof couldn't decide between one of them and had to put two. So, you know, so really, do we need to change the students? The students have just adapted to reality. You know, it's kind of Darwinian. You know, they adapted to the situation. They've developed strategies that, quite frankly, probably work. So why are we going to change the students? Why don't we change the profs, and the students will follow afterwards?
I think, though, that as educators, we do need to be aware that we're shaping students to be learners ourselves. So I think there needs to be from both sides. So we need to teach students how to actively learn and actively use these processes. And I think through the use of Think-alouds, we can do this. So having students use Think-alouds when they're going through questions, this is going to help both the student and the prof, because both students and educators can monitor their reasoning process. So they can start to actually be aware of where the reasoning kind of breaks down. It also helps profs or educators because they can specifically see where the connections are happening and actively help the students bring or retrieve knowledge that they have and make connections. So they can kind of break down and see where students are going wrong. And so can students. I don't know if I really answered that, but
Well, I understand your point.
but it's a really good point to think
accept it.
about.
I mean, it's you know, it's hard to change students. There's a lot of them.
Yeah.
And I think one of the issues is that there's such poor quality MCQ development generally.
Yeah, we really have to be worried about the alignment.
Strategies that students have adopted, we can say they're bad strategies, but they're probably good strategies for bad questions, is kind of my point.
But it's sort of to the same point, but I would say, like, it would be really useful to continue this line of research in a particular direction, in that, like, I can tell if I look at the results, like the biserial correlations in, you know, the exam question result, you're analyzing all the questions, is it a good question or is it a bad question? Mm-hmm. But really what it's telling me is, like, okay, like, a good question will differentiate between the students that aren't strong and the students that are. So like all the ones that are the high performers do well on this question, the others don't. But the question is why? And so in a sense, is it like the poor performers aren't getting it because they don't have the strategies, or they don't think through the problem or the question adequately or in a logical sequence or something to get it? Or is it that the other, the strong students, have some other strategy that's superior, I mean, there'd be a lot to unpack about this to determine, is it a bad question, or is it something about the way different types of students interpret the questions?
Yes, yeah. Because we did see that in some of the questions where they were getting it wrong, a lot of students were applying many strategies, and they're still getting it wrong. So it might be more beneficial to them to have specific strategies that they can use to actually solve that question. Mm-hmm. But I think it does have something to do with the question alignment to what they're learning.
And it's fascinating that the ones that apply personal experience more likely get it wrong.
Well, they likely get it right in the oral think-alouds.
Yeah.
So it's nice for that one because we said oral think-alouds, we can actually get the full description of what they're saying. In the written think-alouds, it was likely in I and E, but not the connections. But we don't know from the written, they would have just circled, I made a personal connection. So we're not too sure if that connection was the correct connection that they made. Mm-hmm. So looking at think-alouds as professors or educators, we can see the connection that they're making, because we know they're going to make them, but is it the right connection?
I was going to say, I'm guessing the 6 questions that you picked, you also picked them because not only they fell within your ICE framework, but that they were well-written questions. But I think it would be interesting to look at how students troubleshoot in the same way and think what strategies they're using in questions that are actually poorly written.
Yeah.
And if that's differentiating students that actually do well versus students who maybe don't do so well, is that the students who use the strategies effectively, even maybe when the question isn't ideally written, and maybe that's why those students maybe are achieving a little higher.
Yeah.
Mm-hmm. Yeah.
That's a good point. I was thinking what you were saying, Rosemary, about maybe it's just a poor question. In this
We don't
case,
know at this point.
At this point, the questions were constructed for the study.
Yeah.
So not necessarily with the idea of let's compare a poorly worded question. And like you said, Richard, students are smart. I mean, they will pick up on how we're engaged.
I wanted to ask about you. I mean, I was intrigued by the one narrative you had, and you highlighted the student, what my friend said or something like that. And now I'm going to talk about personal experience again. And so my daughter's in first year, and so she's learning how to do this stuff at the university level. So I get phone calls, and something that's very different from when I went to university is they do a lot of these things online as formative assessments, and there's a value assigned to them, small values. And so, what do? They all sit around together as a group and try to answer questions. I don't remember us doing that as much because you didn't submit them that way, but, they sit around and, she says, it takes hours for them as a group to decide how they're going to answer these questions. So, what's this? To me, that's an interesting thing. What's this new-ish idea of, how influential are your friends? And then what's then the value of that? Because there is value in them sitting around and actually arguing out the answer to this question. Whether they get it right or wrong is actually probably inconsequential. What's important is that they argue the points back and forth.
Yeah.
And who's the one who's willing to go against the friends? Right? Who's the one who's going to say, I don't care what you guys are going to say, I'm answering this. That's fascinating to me.
We had this conversation in a course I taught a few years ago where we had implemented weekly online quizzes, and they were just to show that for them to do something before coming to lab. Yeah. And we knew that they were doing them as groups because we'd see them in the library. There'd be 10 or 12 of them all sitting around a table doing them, and we kept saying is it worth it for us to restructure the course so that they're doing them individually because they were assessed. But we thought, you know what, they're sitting around for an hour talking about these questions, and that's their prep for the lab, sure. So we left them as...
25 questions with 3 hours.
Yeah.
a conversation about 25 questions.
Yeah, that's amazing.
You know, there's value in just that, right?
Yeah.
And so, how do we recognize that? How do we make questions where all the answers are right, anyways? It doesn't matter what you answer, or what's the
Exam.
The two-stage exam that is being used in physics, that's how they take advantage of that. So their final exam, it's a two-stage exam. So the first hour, students write it on their own.
Right.
And then the second hour, they write it in groups. And they've tried different things where students pick their own groups. And they've tried where students are assigned a group, and they didn't see a difference there. So that's, I mean, some people do take advantage in the final exam, where it's the two-stage. And I think, Mackenzie, that was not your only quote. There are several that reference their peers.
Yes, yeah. It is nice too because even that kind of back and forth, they're starting to create connections themselves within the content, which they might not make alone necessarily. So actually we're at the end here. So just going over the learning objectives. Hopefully now you can be able to distinguish between the question types of the ICE model that we used, be able to define domain-specific versus domain-general, and to analyze what strategies students are using for each question type. And lastly, to be able to identify teaching methods that can narrow that gap between expert and novice thinking.
So Mackenzie, what do you mean there? Do you mean so at the expert stage where our learning is structured in a web-like format rather than hierarchical? So where students oftentimes would say, oh, the prof went off on a tangent. It's not necessarily that they went off a tangent. It's because they're seeing all those connections.
Yes, and novice educators are more like a linear. They can connect some discrete facts, but it's not in that kind of web-like connection that experts have. So important note is making that learning visible to students, having those experts explicitly show how those web-like connections are made and how they're making those. Any other questions, comments?
So based on what you've learned here, what would you say your advice would be if, like, we're trying to, say, coach students to succeed to the best of their ability on, like, national board exams, which are all multiple choice?
Yes. So I do think
Mostly connections.
it would be nice to have an expert or the prof or the educator to model going through a few, model their strategies, their connections, but it also needs to have that guided practice. So they need to be the ones showing their thinking and going through the reasoning that they have.
So would it be advantageous? Like, I think a lot of people do study in groups, and so they would have this interactive thing around the material and how to think through what's going on.
Mm-hmm. Yeah, I think so.
I mean, because it's pretty labor intensive, I mean, you'd have to have like a good question set that you thought was
Yes.
similar to what they would be encountering, right?
Mm-hmm.
So you can either do it as a session where people, you know, it's kind of individual doing the.
And Rosemary, you were thinking of the national exams, right? Where you
Yeah.
don't necessarily document the process. You just circle the answer.
Yeah.
Yeah. So if you want your students to succeed, you know, I mean, I'm mindful that, like, if you give an exam and half of it's multiple choice and the rest is short answer or scenarios, it never fails that, like, there's a very thin group of people who will be like the top performers on both. But the rest, the ones that do really poorly on the multiple choice, they'll hit a home run on the other part, so they all end up kind of passing, right?
Yeah.
Or vice versa. The ones that do really well on that do not do on the multiple choice, do not do well on the other. And I've seen it over and over again. It's like some students are just not good test takers on the multiple choice, I think.
And you hear that even from a student's perspective. I'm not good at multiple choice, or I'm really good at it. I hope there's multiple choice.
So those people
Stigma.
get into trouble when they go into a fully, you know, like a 4 or 6 hour multiple choice exam scenario.
Yes. Yeah.
So that's where.
So thank you for your presentation. Part of my research is focused on metacognition and the development of it. So I was really interested in your finding around the fact that those who were more metacognitive didn't necessarily get more correct answers. So I was wondering if through the Think-alouds you were able to determine if that's just because they're utilizing the strategies incorrectly. Because one of the main reasons why we're always preaching about metacognitive development is that it leads to greater success academically and outside of the classroom.
Yeah, we were surprised to see that too, that the more strategies that they used, the more likely they had it incorrect. And I'm not sure if we kind of figured out the exact reason why. More so the reason that maybe that they're just trying every strategy that they can, but they're not finding specifically for an extension level that they should be doing one strategy over another.
I also wonder if maybe in the past they've just had experiences where the strategies have been modeled incorrectly
Yes.
to them as well. So they're, again, applying them incorrectly.
And some of the written Think-alouds, again, we had the questionnaire, but we're not seeing, from the oral ones, we can see their full description. We know that they're using them, but in a questionnaire, they may think, oh, yes, I did that, I did that, I did that. Did they do it? Did they not? It's based off what they had said.